Hello everyone. So today we're going to be talking about the chapter called data structure. And in this chapter, data structure, what are we learning in this particular video? Okay, I will be introducing you to the term called data structure. A specific data structure that we're going to be dealing with today is the linear list or the array. And I'll be talking about certain operations that we perform on arrays. And I've written a 1D array. I will just explain to you the difference in the next slide. Is that clear? Okay. So now what exactly is a data structure? Data structure is nothing but a logical way of organizing data so that it becomes very efficient to use. Now some of you might say the list, the tuple, the dictionary that we see in Python is also organizing data in a logical way. Okay, so are they data structures? Yeah, some of them term it as a data structure. They're called the built-in data structures of Python. But this facility of a list and a tuple and a dictionary is available with Python only. These are not data types that are available in other programming languages. Okay, so when we talk about the chapter called data structure, we are talking about data structures that is available in any programming language. Clear? Okay, so that's the reason we are going to be dealing with this chapter. Though we have some built-in data structures, we used to call it data types. They can be termed as data structures as well. Okay, as lists, tuples and dictionary. But when we talk about data structure chapter, we're talking about in general which is available or with respect to any programming language that you learn. Okay, so according to your syllabus, you are going to be learning 3 types of data structures available any programming language. One is called a linear list. It's also called an array. Now don't get confused between linear list and the list data type. I'll tell you the difference shortly. Another data structure that we're going to be learning in this chapter is called stacks and then queues. But in this particular video, we'll be only concentrating on the linear list or array. So now what's a linear list? It's an ordered collection of elements. Now list data type of Python is also an ordered collection of elements. But if you remember the definition of list when I specified, I said it's an ordered collection of heterogeneous or homogeneous elements. That means the data within the list could be all of the same type or of different type, doesn't matter. But in this scenario, what happens is when you talk about a linear list or when you talk about an array, all the elements of the array or the linear list have to be of the same kind. That means linear list or arrays are homogeneous elements. Okay. Now this linear list or arrays are of 2 kinds. We call it a one-dimensional array, where each element of the array can be indexed or can be identified, by one index value. Okay, or there is 2-dimensional arrays where each element is identified by 2 index values, the row as well as the column. Let's not get into details of 2-dimensional arrays now. Okay, I will show it to you lately. But when you look at the examples given on the screen for 1-dimensional array and 2-dimensional array, it's exactly the way we write a list. We could say a 1-dimensional array is a regular list and a 2-dimensional array is a nested list. Is that clear? Okay, let's start with 1-dimensional arrays. Now what are the operations that you can perform on a 1-dimensional array? And whatever operations that I specify here are going to be learned by anybody learning any programming language. That means when you're talking about 1-dimensional arrays, you need to know insertion, deletion, sorting, searching and merging. In this particular video, in this part of the video, I'll be only talking about insertion and deletion in 1-dimensional arrays. Okay, so are we good to start? The other parts, that is searching and merging, will be done in the later videos. Sorting we won't be doing because we've already done a topic called sorting techniques and we have used bubble sort and insertion sort. So what exactly is a one-dimensional array? I am going to be creating a one-dimensional array using a list, because list basically is a one-dimensional array, or is an array as long as I store all elements of the same kind. So is there something called an array that I'm going to create? Yes, I'm going to create an array, but I'm going to create an array using a list. Now all the three data structures that we are talking about in this chapter, that stacks, queues and arrays, I'm going to be creating all the three using the data type list of Python. Clear? Okay, let's talk about the functionality or the operation of inserting something into a list. Here we're talking about, the first program will talk about how do you insert a particular element at a particular location. So you have a particular element and you also have the location. You're supposed to be inserting this particular element at the specified location. Is that clear? Okay, so first of all, I need to be creating an empty array. So I have created an empty array there. Okay, let me just use my pen there. Okay, so here I have created an empty array. Then I'm asking the user that you enter how many elements do you plan to be putting into this array, correct? So he says, 5 or 7 or 10. Then what do? I loop through. These are all basic lines for us. I loop through the element. I create a loop. I ask the user for an element, and whatever element he enters, I'm storing it into my list called L using the append function. Now here we are making use of the append method of the list class, okay, because we've already learnt list chapter. So what is happening, one at a time, I'm taking an integer from the user and I'm storing it into a list called L. Okay, so here I'm not using the eval method of reading it from the user. I'm reading one element from the user at a time and just adding it on to the existing list. Clear? Okay, then what do I need to know? I need to ask the user what's the element that he wants to insert and at what position does he want to insert. Okay, so basically let's say this is your list. Please excuse my diagram, I'm just using the mouse to do it. Okay, so I have 3, I have 4, I have 7, I have 8, I have 10. Okay, and the number that I wish to insert is 5 and I want to insert it at location 1. Index location 1. You remember the index values of these? So you have 0, 1, 2, 3 and 4. So basically where do I want to insert it? Here. But if I insert it there, it doesn't mean I'm overwriting 4. I am inserting 5 there and 4, 7, 8, 10 all get shifted to the right. Okay, if it was any other programming language, what would the logic be used for doing this kind of insertion? You know what we do? We start from the last location of the array and start transferring the elements one position to its right. So 10, which was at location 4, I would transfer it at location 5. 8, which is at location 3, I would transfer it at location 4. And all this transferring takes place till the location I want to insert the element, and then I go and insert the element. But that's not required with Python programming, is because in Python programming we already have a method called insert. Correct? You remember? So it already allows me, so it does the shifting automatically. The method is doing the shifting. So I'm just making use of the insert function. But why did I tell you this logic is, if you will ever learn any other programming languages, you would have to write a loop or some statements which will do the shifting of all the elements and make an empty location for you to insert the element. Clear? Okay, so now I wrote if position less than or equal to the length. That means you have given me a position which is a part of, your so-called array. Only then I'm going to do insertion. Now in this array, what's the location? 0, 1, 2, 3, 4. And he says he wants to insert 5 at location 10. Now when you talk about location 10, it is not a part of the given array, right? So I'm not going to be inserting. I would say, sorry, cannot perform insertion, my last line, at this location, because then what would happen? I would have some elements in the beginning, suddenly no elements, and then one element. When we say array, we are saying an ordered collection of elements. So you're not going to be leaving some things blank in between, right? So as long as the position that the user wants to enter is less than or equal to my length is going to give me 5. So as long as he chooses any index number from 0 to 5, I'm okay with it, I will insert. But if he chooses any other position, I am not going to be inserting, because I would say that you can't be inserting at this location. So I made use of the insert method of the list class. And if you remember, the insert method of the list class requires the position and requires the element to be inserted, and it automatically does this shifting out and this inserting. So in the method, there is this logic. But like I said, programming languages which do not have the insert functionality or the insert method, you would have to do the shifting and insert the element. Clear? Okay. And remember, after inserting, the number of elements in the list or the array or the linear list that I'm talking about is going to increase by 1. Is that clear? So this was talking about insertion of an element at a specified location. What if you want to insert an element in an array which is already sorted? So location is not going to be given by the user. You need to find the location. Now, for example, let me just draw the one-dimensional array. Okay, and why do we call it one-dimensional array? Because every element in this array just needs one index location to identify it. The first element being at index location 0, the last element being at index location as length minus 1. Okay, so let's assume this is 1, this is 5, this is 8, this is 11, this is 15, and this is 23. Now the number I want to insert, they're just giving me the number that I want to insert, and the number I want to insert is 7. They are not telling me the position. They are telling me that the number to be inserted is 7. So how do I go about with that kind of insertion? Now I know the number 7 has to be inserted here. Now why do I say that? Why do I say that number 7 has to come there? Because when I compare 1 with 7, is 1 greater than 7? No. Is 5 greater than 7? No. Is 8 greater than 7? Yes. So the minute you find an element which is great in the array, which is greater than the number that you want to insert, then that is the location where the number has to be inserted. Clear? Okay, so how do we go about with this? How do you find the location? Very easy. I already spoke the logic about it. Okay, now this is just reading the elements that we saw in the previous slide. Okay, I'm asking the user which element he wants to insert. Remember, I'm not asking him the position because I am going to find the position. Now I say position is len of L. Now in this scenario, how many elements do you see? 6. Right? So len of L is going to give me 6. Initially, I'm saying position is 6. Now, why do I say that? I am assuming that I want to insert this element at the last location. That will be position 6, right? So I want to insert this element at the last location. I'm assuming, initially, assuming this is a bigger number than the elements existing in the array. But in my next loop, what am I doing? I'm starting from index location 0 to going up till 5. What am I doing? I'm finding an element which is greater than the number that you want to insert. So if L of I, what is L of I initially? 1. 1 greater than 7? No. So will I be doing these two lines in the if statement? No. 5 greater than 7? No. 8 greater than 7? No. Oh, sorry. Yes. Yes, correct. So what did I get my position as? Position, which is 6, now becomes a value of I, which is 2. Have I got the position with me? Yes. And I say break. Why break? Why is break important here? Because if I look at 11, 11 is also greater than 7, 15 is also greater than 7, 23 is also going to be greater than 7 because this is a sorted array. So if 8 is greater, everything after 8 is also going to be greater. I'm not interested in all the elements that's greater than 7. The first element that is greater than 7, I got the position and I execute a break. That means I stop executing the loop. What's the purpose of the break statement? Stop executing the loop when you encounter the break. Now did you get the position? Now you already have the position. You have the item. What will you do? You will insert the element at that particular position. And after that, you are going to print the array. Now you might have seen I've put a semicolon after the insert statement. Yes, you can involve semicolons also like C or C++ language to say that you're going to be writing two statements on one line. Can you see I have the insert line and the print line written on the same line? Reason is I did not have place below, okay, to show it to you on screen. So I put it in the same line. But remember, if you're putting two executable statements on the same line, you need to be putting a semicolon. Clear? I could have had many more statements. After every executable statement, you could put a semicolon. Is that clear? But you need not be, if you're making a note into your books, you can just write it on the next line and just avoid the semicolon concept. Clear? How did we find the position? And then inserting we used the method. But let me tell you one thing. If it was any other programming languages, you would get the position. Then you remember I told you to write a shifting loop, start from the last element and keep shifting. Same thing you would do here. But Python makes it a little more simple for us because it already has a method which does the shifting for us, which is our insert method. Okay. Now coming to the last of the operations that we're going to be seeing in this video, it's called deletion. Deletion is obviously to delete an element. Now Python also has a method to do deletion, so it becomes very easy for us again. Okay, so I'm going to be asking the user to enter the elements into an array. I call it a linear list or an array. Okay, when I just say list, you may talk about the data type called list, where elements could be of any kind. Here all elements, remember, are homogeneous elements. Okay, then I'm asking the user the element that he wants to delete. Okay, so let me just tell you the regular logic of what would have happened. So this is 3, this is 1, this is 5, this is 6, this is 2, and let's say this is 9. Okay, and you want to delete the element 1. In other programming languages, first of all, we locate where is 1. After we locate where is 1, then the shifting takes place. This gets shifted here, this gets shifted here, this gets shifted here, and this gets shifted here, and that's how they perform deletion. So in insertion, we were shifting to the right. For deletion, we shift to the left. But we don't have to worry about that here because we have a function or a method called remove in the list data type, in the list class, which will help me to delete. But only thing is, I need to know that the remove function, if the element doesn't exist, just gives you an error. So what am I going to do? I'm going to be keeping a track of, does this element exist first of all? So just look at this function. I wrote if L.count, you remember the count function? So I'm checking if it's not equal to 0, that means it does exist. If it exists, what am I doing? As long as, what does the while item in L mean? As long as the item exists in L, keep removing. Now some may ask me, ma'am, why didn't you just write L.remove item? Because that's how we have learned. Correct. L.remove item removes only the first occurrence of the element. What if the number that you want to delete appears multiple times in the list? Don't you want to delete all of them? Correct? So in that scenario, we make use of the while loop. It says while item, while the number is in the list, you keep deleting. So you suppose 1 was there 3 times. So this loop would be executed 3 times and it would keep removing the first occurrence, the second time the first occurrence, because the second element now becomes the first occurrence, and so on. So the loop is required if you're planning to delete all the occurrence. Now let me tell you one thing. If the question says delete, you can perform this. But if the question says delete the first occurrence, then in that scenario, you don't need the while loop at all. You will just write L.remove item. Why? Because remove is anyway going to be removing the first occurrence. Is that clear? And then I'm displaying the array after the, sorry, my correction here, children. It's not array after insertion. It should have been array after deletion. I'm sure I must have just copied the the statement from the previous program. Otherwise, that means if the count is going to be 0, what does it mean? That this element that you want to delete doesn't exist in your array. So you could give a message element found. Is that clear? So did you understand the working of an array? Remember, we are using a list. We are creating the concept of an array using the list data type. Clear? Similarly, for stacks and for queues, we'll be using the list data type. Okay, so I hope things are clear. In the next video, next part of the video, we'll be learning the other operations that you can perform on a one-dimensional array, slowly move to two-dimensional arrays, and then talk about stacks, and then talk about queues. Okay, so each of these videos will explain to you each of the data types that the data structures that you need to be knowing from syllabus point of view. Is that clear? Okay, thank you.